Hi, I'm Josh Suereth. I'm one of the nerds at Typesafe that works on Scala. I wrote a book on Scala that should be released soon. It's amazing how long it takes to release a book. It's called Scala In Depth. It does not cover SBT. But that's what we'll be talking about tonight. So this talk is geared to give you an introduction to the concepts behind SBT, how it works, why you have keys, why you have these initialize and tasks and that sort of thing, and the general concepts behind how you construct a build in SBT. And then we're going to go over a few examples of cookbook-like things for how you can do some complicated stuff in your own build. So the basics. First off, in SBT, you define a build by creating a Scala file in the project directory. You import SBT and you extend the build class. Inside of the build class, you define a whole bunch of projects. The projects can be local or they can be remote. SBT can actually materialize projects from Git and build them inside of a sandbox for you, and you can depend on them and add settings to them and all sorts of craziness. I actually use this a lot. It's a more advanced thing, but it is very handy. Projects are a sequence of settings. So again, if we look at this, build, project. Projects are made up of settings. A setting is a key and initialization pair, right? So a key is a name, an initialization is like a value or something that computes a value. So we'll get into that more. But this is the essential structure of SBT. Everything in SBT hinges on this basic concept: build, project, settings. Okay. Here's an example build. I might start pointing this way. Yeah, nice. I like that. All right. So here I define an object, my build. I've defined one project called Scala Awesomes. This project is located, if I move this, in the current directory. So although my build file is in a project/build.scala file, the root directory is considered the root of the project. That's what that dot refers to. And when I define a project, there is a settings method that I can call on project to add settings to the defaults. Okay? SBT comes out of the box with a whole bunch of default settings that should do the right thing for a lot of open source projects. It may not do the right thing for you, or it might not have enough, so you have to add configuration. And that's what this method does. What I'm doing here is I'm setting the organization and the name. For those of us from Maven, like me, organization is group ID, and name, I believe, is name. So anyway, you can also specify version and things there. This next method call here is a depends on method call. I'm using a little bit of simplified syntax to make this fit on the slide well. So this is the opening part of that settings call. Here's the closing part, just so you're aware of how that flows. Anyway, so I'm depending on another project, ARM. This is a project. This is a subtle hint that I wrote another project that is actually useful. Anyway, Scala ARM. There's the GitHub URL, right? I'm defining this as root project. Root project is a special class in SBT that denotes that the URI that I reference here, or the file that I reference here, has its own build. And when you pull this in, you need to pull in that other build as well. So I'm literally pulling down things out of GitHub, compiling the project for ARM, and then I am attaching this as a dependency to Scala Awesomes project. I can even do more things like append settings and change the config that I've pulled in, but that's more advanced. The basic is that if you want to depend via source in SBT, it's possible. The whole system kind of scales that way. The core of SBT is the setting. A setting is a key and an initialization. You saw earlier in this build that I set name, and then I have this funny colon equals method, and then a value, right? So keys are objects in Scala, I am referencing name from the sbt.keys object. Here I have imported sbt.keys._. Name is a member of keys. I'm calling a := method, which takes a key and takes an initialization value on the right-hand side, associates them, and becomes a setting. Okay? So in SBT, all settings are, I have a key, I have some sort of assignment operator that determines exactly how I'm going to associate an initialization value. And then on the right-hand side, I have an initialization value. Okay? That's how everything in SBT operates. There are several types of these. There are a bajillion types of keys, and initializations are up to what you write. So key types. We have 3 key types. We have a setting key. It's confusing that we call these settings, and we also have setting keys. But anyway, setting keys are things that when the build loads and we resolve dependencies and run the initialization, then that setting is done. It's kind of like defining a value in Scala, right? That value is initialized and doesn't change unless we reload the build. So settings are things like name, version, organization, and they're supposed to stay the same. Tasks are things that are recomputed every time you run them in the build. So a task is something like compile. When I run compile, I need to go look at your source, figure out what's changed, compile that code, and then return some result. And then there are also input keys. For example, SBT has a run main input key. Run main basically takes user input in the SBT console, uses that to generate a task which then runs. Okay? So an input key is a task generator. Anyway, I hope I'm not going too fast with some of that stuff. Hopefully, this will be a little bit more apparent when we hit assignments. As far as how I can assign things, I have a direct assignment. For the name key, which is a setting, I can use that : and have a value on the right-hand side that assigns to the name, right? So that's a setting that will set it to name. No matter what was there previously, name will now be foo after that setting takes place, okay? I can have a dependent setting. This little dash equal or less than equals operator is a dependent setting. So what this says is set organization to a value where you take the current value of name and run this code, this function against the value that was in name. So I'm taking the existing name and I'm adding com.jsuereth and then the name right after that. So it'd be com.jsuereth something. And that's what my organization should be, right? So one thing you notice is that organization is dependent on the value in name. So in SBT, a project is made up of a sequence of settings, okay? If we go back to that build file, I defined a setting here and I defined a setting here. Now, in organization, I can depend on the value of name and then have an initialization that depends on that using that less than equals. What SBT does is it will actually discover that organization has a dependency on name, okay? When SBT starts up, it takes all of your sequences, or all your sequence of settings, it kind of tries to compress them all down as much as it can, okay? I can have the name actually depend on a previous name using the syntax. So I can say name less than equals name, apply, right? And so what that does is it looks for the previously set name in my sequence of settings and changes the value. Okay, so the settings in the build are kind of, SBT falls through them, okay, and figures out values and does things as you make a build. It's a little bit complicated to think about, right? But essentially, things flow down, right? We get this linear sequence of settings. SBT figures out all our dependencies, and then it can tell us what our dependencies are. So when it's done with all this initialization, SBT can tell me that, hey, name depends on, or organization depends on name depends on something else, that sort of thing. And it does so because of how this setting works, right? This name.apply. All right. Another thing I can do when I assign things is this library dependencies key, right? Library dependencies is a sequence of libraries to depend on. So there are two special operators I can use called plus equals and plus plus equals, where I can put either a library on the right-hand side or a sequence of libraries on the right-hand side, and it will append them to the previous value. So remember how I said you can have less than equals on a previous value? This code is akin to, sorry, should have prepared this. Come on. So if I were to write, can you guys see? Let me make this scroll down. Okay, so if I were to write a setting of library dependencies right? So I'm relying on the previous version of myself. Actually, it's apply. And then I'm adding a new library, right? So let's say L was a library. What this is doing is I'm setting the new value of library dependencies to be equal to the old value of library dependencies, and I'm applying this transformation function on it, okay? That transformation function takes the old sequence and adds a new library. That is shorthand or that is longhand of this. The plus equals operator, all it's doing is it's taking the previous value of the setting and it's appending something to that sequence. The plus plus equals is appending an entire sequence to the previous value. So it's a handy way to append junk to sequences. There's a lot of sequences in a build tool. Yeah. Library dependencies happens to be the key is a sequence of projects, right? So when I define keys, I don't think I showed this. Setting keys, task keys, input keys. Keys are defined with a type, and that type is the value that's returned when I evaluate that setting, right? So the name key has a type of string. It expects a string on the right-hand side that it's going to compute. The library dependencies key has a type of a sequence of dependencies, a sequence of library dependencies, right? That are the actual type in SBT is module ID. So yeah, when you define a setting, you also define a type associated with that setting. When we get to the examples in the cookbook, a lot of that will become a little bit more clear. So that's actually the basics of SBT. Everything is, we define a build with a set of projects, we define a big sequence of settings, SBT follows through and tries to collapse all these things and figure out dependencies for us. And then when we type something into the SBT command line, it is one of these key names. So name, you can, inside of SBT, type name, or actually I can type show name because I have to type show to have it return stuff. This is the XBT extras plugin is the setting for name, right? I can show any of these settings. If I type show compile, it's going to look kind of stupid, but it's going to compile the project and then it's going to show me the output of compile. The output of compile is this analysis object of like what changed in your source code, and it doesn't have a toString method. So you're just going to see like analysis, at and then some hash code because it doesn't have anything useful to it. Oh, actually, no, it looks like it might. Yeah. Okay, so it wasn't useless. There we go. It told us how many Scala sources and classes and things changed. Right, so any setting we can type in the console, show, and then that key value, it will go execute it and tell us what the result of that value was. Okay. SBT has scope. Keys can have different values in different scopes. So this is where things get a little bit more confusing. Before I had name, and I can set name, equals, instead of SBT extras, I can set it to Josh. And now If I type name, I see Josh, right? There are scope. Scope are things like I want to take a set of settings and I want to define how to compile Scala code, right? How to compile Scala code doesn't change whether or not I'm building my tests, whether or not I'm building the actual project, whether or not I'm building my unit tests, or integration tests, unit tests, whatever. It's the same, building Scala code is the same for all of those. It's just a matter of getting the right settings into that, sequence of tasks that run. So in SBT, we have something called scope, where we can take a series of settings and move them into a scope. So in SBT, there is a definition for how you compile Scala code. We take that sequence of settings and we move it into a compile scope, and that's how we compile your main project. We take that sequence of settings, we move it into a test scope, the exact same sequence, and now it can build your test code. So the way that we reference this in SBT is there's a syntax, it's in. So we would call sources in compile refer to the sources sequence of files that will get compiled when you compile the main project. Sources in test are the sequence of sources that are compiled for your unit tests. So scope is essentially a way of scoping these keys, so they refer to a particular flow. And you can define different flows. Scope should be reserved for big flows, right? Like if I'm compiling Scala is an excellent example. There's a lot of different settings and things to configure Scala. You need to do your Scala C options, you need to pick a bunch of sources, you might have compiler plugins, you have library dependencies. There's a lot of settings that go into that, so you can define in your build one sequence of settings and reuse it for every time you need to compile Scala code. Okay. The other thing is that configurations can extend from other configurations in a sort of OO way. So the test config, I believe, extends from the compiler config. So if I define a setting that relies on something in the test configuration and that doesn't exist, it will look for something in the compiler configuration before giving up. So that's what extends does. It will go down that hierarchy in the config looking for keys. Yeah. So, right, keys can also be scoped by a task. So this is a very interesting addition in SBT. The one that I know that's specifically done with this, SBT will generate a jar file for your sources. It will generate a jar file for your classes, the binary, and it will generate a jar file for your Scala docs, right? And those are the package command can do that. There is a mappings key. A mappings key in SBT is a sequence of file to string tuples, right? So mappings is essentially I have a set of files and I have a set of locations that I want them to exist in the resulting jar file. And I want to reuse that key every time I need to do something relating to mappings, right? Or where I map things to go into a jar. So to do that, SBT actually can scope things by a task as well. Package bin is a task. That is the task that will package up your jar and all your classes. So mappings in compile, package bin refers to all of the class files that will go into your jar and the resulting location in your jar. Not just your class files, it's also your resources, right? It's everything that gets packaged in your deployment jar. Mappings in compile package doc refers to all of the HTML files and CSS files and things that end up in your Scala doc jar, which I believe is called Java doc because Maven's fun. They don't want us to rename it. If I want to look at these things in SBT, if I type mappings, it's going to tell me that I don't have anything. I don't actually have any mappings, but I have something defined for compile mappings. Actually, hold on. Yeah, I don't have anything defined for compile mappings either because it's defined specifically for package bin. So if I show my mappings for package bin, It's going to resolve the internet and then build my code. And then it's kind of hard to see here, but these are tuples. This is a class file, the late build project class file, and then where it's supposed to be installed. So here's a decent example here that's hard to see. Template build tap.class goes under template build tap.class. That's the key value pairings for mappings. And you can see how I reference it inside of the SBT console is the config comes first, then a colon, then the key, and then the task it's scoped by. So if I run this for package source, we'll see a different set of files. It's a lot less because there's only like 2 source files in this package. Right, so scope is possibly the most confusing thing in SBT. Applying values to keys, once you get the feel of it, is really easy. Scope is where the complication comes in, because when I'm trying to figure out how to add something into like the resulting jar file, I need to set it in the right scope. So it's not just enough to add it to the mappings key. I have to add it to the mappings in compile package bin key, right? So how do I know which key to use in SBT? There's an inspect command. Anything I do in SBT, I can inspect. The inspect command tells me the compile task returns the type SBT inc analysis. That's the value that it returns when you run it. It has a description. It tells you where it's defined, right? So who provides this task, and it tells you what it depends on. So it only has 2 dependencies. Compile inputs is a key that actually aggregates a whole bunch of information about compiling. So that's not just your sources, it's also your flags and that sort of thing. And then streams. Streams are that's your logging in SBT. Anyway, if I need to deconstruct what settings I need to configure, I can use inspect to look at where everything is. Yeah.
Can you talk a little bit about what streams are?
Streams? Okay, so SBT, whenever you run a task, any sort of task, SBT will log everything that happens, and it won't necessarily show it to you. Like when I ran that, it showed the result. When I ran package, it showed the result of mappings, but it didn't actually show me the output of the Scala C compiler. So in the target directory of SBT, there's a streams directory that has all of your logs. The streams class, or the streams key in SBT, is a way to access the logger. So inside of a task, if I ever need to access logging, I can depend on streams, and I will get an instance of it, and I can make use of it. We'll cover that later, I think. Right. The other interesting thing about inspect is I get my reverse dependencies. So these are things that depend on me. So if you want to know who's using a key, to know if it's safe to change it, you can check your reverse dependencies, and it will show you, for example, compile products depends on compile. So compile products is the thing discovered main classes is the thing that SBT uses when it sends you a prompt of like, when you type run, and it asks you what main class you would like to run. Discovered main classes is the key that computes that. And it makes use of compile. So if you want to inspect what's happening in SBT, there's an inspect command to dig into all these keys and their dependencies. Yeah, so that is scope. We're going to talk a little bit about initialization. So a setting key has a type associated with it, right? A name is associated with strings. Names can only take instances of strings. There is a class called initialize. Initialize is it kind of wraps a function of no arguments that generates a T, okay? Task keys take an initialize of a task. So what SBT does during startup is it takes all of your settings, it takes all of these initializes, it looks at all the dependencies, it calculates this huge dependency graph from these initialize, and it will actually grab values. For settings, remember we said they're calculated once when the build is loaded. we actually get the raw t and place it into the setting. For these task keys, we generate a task. The task is a function that will be computed later. So yes, initialize is a function that generates a function that will be run later. So deferred work. Any key reference can be converted directly into an initialize. So if I want to set the name to the value in organization, I create a setting like this. So keys automatically become initialize. Initialize is an applicative functor. We'll go into those a little bit. But if you notice in this code, we've been showing there's an apply method on here. Apply is from initialize. Apply allows you to take an initialize of a certain type and transform it using a function. So name becomes an initialize of string, right? So I have something that will give me a string, and I am transforming it by a function into something else. You can think of initialize as a pseudo collection of one thing, right? And I have all of my apply, map, those sort of methods on it. What's weird is that initialize task of t, it is very inconvenient to have to nest inside to task. So SBT has a way for you to map directly on the t rather than having to know that you're dealing with tasks and not just initialize a t. Right, so SBT uses a concept called applicative functors to allow you to access t or initialize or task t, the t inside of initialize task t, similarly in the build to construct these initialize values that get applied to settings. So here's a little digression. We're going to cover a little bit, a very base level of applicative functors for you. So imagine that I have a method called getConnection. It looks very similar to what's on Driver Manager. And imagine I have a bunch of options that I've got from user input that may or may not be there. So I have an option of string for URL, user, and password is an array of character. So what I would like to do is I'd like to make use of URL, user, and password to create a connection, right? However, each one of those is inside of an option. And getConnection takes the raw types. It doesn't take an option of string. It takes a string for user, right? I need to get inside of there. So one option that's kind of a pun, I can use a for expression, and I can rip the values out of URL, user, and password, right? So the for expression will pull each value out, and then I yield a getConnection of those values, and I will have an option of connection. So using for expressions in Scala is a way to pull those values out of the container, right? That's what for expressions are all about. The downside is that this is not applicative, and there's a reason why we care about applicative. For expressions are sequential, okay? I have to pull the value out of URL first. If it exists, right, then I will pull the value out of user. If that exists, then I'll pull the value out of password. But at the top level, I don't know until I've pulled the value out of URL if I will run any of the rest of this function, right? So if I were to inspect the dependencies of the resulting option, right? Let's say I had something that calculated dependencies, I wouldn't actually know that user and password are dependencies of the resulting connection because these functions that run here underneath only happen when I try to extract from URL. So it's unsafe to try to discover the dependencies. I actually have to run the code because of the way that those methods are defined. Essentially, a for expression in Scala, this code, this for expression, turns into this code. We're calling FlatMap on an option, and we have a function that takes the location of the option and performs some value, right? That's all that this guy knows. He has no way of knowing that there are other dependencies involved here, right? He just has a function that returns an option, and he's going to flatten that sucker out. Inside of there, I have a user FlatMap. You know, that doesn't actually, this user FlatMap never gets called if URL was available. So FlatMap is not ideal for a build tool, right? When we're talking about initialized values, if I'm talking about making a dependency on compiling my tests and compiling my source code, actually a better example is if it's running my tests and running my integration tests, and I want to do those two operations in parallel, right? FlatMap will not let me do that because I have to extract the results of running the tests first before I can run the function that will extract the results of running my integration tests, right? So I can't do the two things in parallel. They have to be sequential. You have to get the result of the one before you can run the other. So for expressions, FlatMap, these are sequential type operations. So what we'd rather do is we would rather use what's called the Applicative Functor concept so that we can get this, we can figure out all the dependencies initially and we can pull their values in parallel, right? That's a key to SBT is that when it evaluates tasks, it will try to do, it'll try to parallelize everything it can. So we need a dependency graph. We can't have a sequential thing of things to run. So what we do is we take the getConnection method and we curry it. If you're familiar with currying, we take a function of many arguments, and instead of taking in many arguments, we take one. So we take in the first string, and we return a function that will take in the next argument, and return a function that takes in the third argument, and finally returns the connection. So we're defining a function that returns a function that returns a function that returns a function. However many arguments we have, that's how many functions we end up returning. And that's currying. In Scala, there's a very easy way to do that. You take whatever method you have, you use this little underscore operator to turn a method into a function, and then you call the curried method on the function, and it will automatically give you this, function that returns a function, etc. Okay, so we now have this crazy big function. Now, I have my curried connection, right? It does exactly what I want. I defined the first part of my transformation as taking the URL and mapping this curried function. So what this does is I take a function that takes a string and returns this big old function, and I map it against the URL. So now I've passed in the first value to that curried function, and I get back the rest, and I end up with an option of the rest of the function, right? So I have an option of a function. So the continuation of the get connection is inside of this option. What's handy here is, because I called map here, this option can remember that it was created from the first URL object, right? I can remember my dependency. Now, I would love to have a way to take this option of a function and to take my user, which was a string, and take the string in the user option and put it in here and do it in such a way that I can remember that that string came from the user option, right? The way that I do that is through an applicative functor. So an applicative functor is a very simple interface. I have a holder of some type, and I want an apply method on applicative, right? So this is the applicative method. It will take a value of the holder. It will take a function that's inside of the holder, and it will apply that function to this one and return me a new holder. And it can do it in such a way that I can remember where I came from and keep track of my dependencies, right? I can parallelize the computation of A and, of A and B, essentially, later. All right. So if I define this applicative and I make use of it, I'm simplifying here. I'm pretending that I've implicitly enriched option with an applicative method that just calls applicatives apply. Okay? So that's a simplification here. But now I can say, I can take this first option of the continuation. I can call user applicative first. Now, since I have user and I have first, this resulting option can remember that it came not only from URL, because up here we're using map, it can remember that it came from user, right? It's not hidden at runtime. This all happens at, during the initialization. I'd never have to extract any of these options to call this applicative method. I can remember my dependencies as I chain through, okay? There's no point where we have to look at the result of one of these transformation functions. We can just make use of them directly. Yeah, so we do the same thing with password, and now we have the exact same result. So what's the big deal, right? They kind of look the same: password applicative, user applicative, URL map, get query, or we use flat maps and maps. Well, the big deal is the fact, again, that these are functions that I need to pull the value out of URL to figure out what the rest of the dependencies are. I can't parallelize the computation. In SBT, that's critical. So that is why we use this applicative style, and that's why you're going to see like apply and some interesting things in SBT. Right. So FlatMap is runtime dependency. Yeah. So here's a fun one. Inside of FlatMap, right, I can write an is, and I can return one value of an option or another, depending on this is prod. And there's no way for me to know what the dependency for the connection initialize is without knowing what isprod is, right? If I run that function, if I run that function with isprod as true, or as, yeah, this should be a Boolean, sorry. If isprod is true, I'm going to get back one version of this dependency tree where it relies on prod URL. And if it's false, I get a different one that relies on dev URL. And the only way that I could know what all the dependencies are ahead of time is to exhaustively send every potential value of isprod into the function, get all the results, and look at all the potential dependencies, right? So SBT supports FlatMap on initialize. We do support it, okay? You can use for expressions. However, you can't parallelize with them. We can't figure out the dependencies ahead of time. We can't do dependency analysis and warn you if you have any sort of missing initialized fields. We can't parallelize your build. It's not a good idea to use FlatMap in SBT unless you have no choice. There are some cases where you absolutely have to. If you run into one of those cases, please email me because I'm really interested to know what that is. Mark has seen one, and I have not seen any. Okay. So SBT has an applicative DSL. Now, I showed before this simple, password, user, URL, applicative map. That's all well and good, but there's a lot of magic behind the scenes that make it somewhat hard to make use of. In SBT, we have it right on tuples. Okay? From any tuple, I can put all my keys into a tuple and call apply, and then give it a function. And this is an applicative functor. It will take all of these keys, it will know what those keys are, keep track of the dependencies, and create me a new initialize where it runs this method against the values inside of those initialize and creates a new initialize. So this is the applicative DSL for SBT. Again, you really want to use this all the time because you will get parallelized builds. SBT has actually really good ability to parallelize how it computes things. Now, here's the annoying part, is if we have an initialize of task, right? Apply will work against initialize t's. Map works against initialize of task of t's. So if I want a task that will generate a connection, instead of generating one at build load, I have to use map instead. This is a common point of confusion in SBT. If I'm dealing with tasks and I have dependencies, I use map. If I'm dealing with settings, or setting keys, I use apply. Okay, it's frustrating, but there's some type inference issues where if we didn't do it this way, you would have to apply a lot of type parameters, and that's Nobody likes type parameters. So here's a cookbook. We're going to cover a little bit of features and how you do things within SBT. And hopefully this will clarify some of the points I made earlier. All right, so if I want to test in SBT, so I take my Awesomes project. Everything has to have a Z in it, by the way, when you use SBT. Just so you know, has to end in a Z. Library dependencies. I can throw this library dependencies key plus equals and then put a module, right? This is the module ID syntax in SBT. It is a Maven dependency. This is the group, this is the name, and this is the version. And then this percentage here defines the config where that dependency will be made available, right? So there is a correlation between configurations and library dependencies. And it's somewhat loose. So this test means when I run test compile, that library will be available. It will not be available when I run compile, right, for my production code. It will not be available when I run integration compile unless integration extends from test. Okay? So that whole config extends thing is somewhat important here. And that's what this last percentage equals. If you don't see a percentage test, everything defaults to being available at compile time. So by default, that would be compile. The last thing is there are two little squiggles there, percentage signs. SBT has the ability to cross-deploy against multiple Scala versions. It added this when Scala had binary incompatible releases for every version, not just major. So this was a way to get around that. So if you wanted to release something for Scala 2.82 and 2.81, you had to release in this fashion. Nowadays, if you want to release for 2.82 and 2.91, that's what you use this for as well. Because Scala has binary compatible in 2.9.x series, you can make use of things compiled in 2.9.0, in 2.9.1, so it gets a little more confusing to do that. To make things work now, that should be fixed shortly. But that's what the little percent is. Yes?
So in some of the libraries, I noticed provided as the fourth parameter without quotes.
Yes.
What does that mean?
Okay, so provided is similar to, I'm trying to remember, I think it's the same in Maven. Provided means I need you to download this jar, I need this jar available to build, but where I'm deploying, that jar will be provided, so if somebody makes use of me, do not download this jar. So it's actually a handy way if you want to have support. So let's say I'm making a new testing library, and I like Scala test. So I want to have Scala test support in my new testing library. I can depend on Scala test with a provided tag here. And then when I deploy my code, people can make use of my library without needing to download Scala test. But if they explicitly declare it, then they can make use of all that Scala test code I have in the jar. So it's a handy way to have like extensions inside of your jar that people can make use of if they have the right dependencies. Granted, if they try to instantiate that class and they don't have Scala test, it'll blow up. So be warned. But that's what provided means. Okay, that should not be highlighted anymore. If I want to define functional tests, what I can do is I can define a new configuration called fun, because functional tests are fun. And I can extend the test configuration, right? So I will get all of my testing libraries in my functional testing settings. And then here's the special syntax right here. In config, fun test, which is the same value here as that fun config. Grab the SBT defaults test settings. If you've never seen this in Scala before, this is how you take a sequence and use it in a variable arguments method. It's just a little bit of sugar that you have to memorize. Right, so in config fun test, this takes all my test settings and moves them into the fun test config. So now I will have fun:test that I can call inside of SBT, and it will run everything, it will compile everything in fun:sources and run them, okay? I can depend on specs and put it in the fun configuration, and it will only be used for my functional tests. So I can use Scala test for unit test and specs for functional tests. That really should be Scala check, because I like Scala check for functional tests. Anyway, right. So library dependencies plus equals specs. Source directory in fun test. Here's where I'm setting a different source directory in fun test. I'm making use of the default source directory and adding a functional to it, right? So what that will do is, you know how there's a source main Scala that by default has all of your Scala source files in Maven? Well, it's also true in SBT. And there's a source test Java that has all of your unit testing. By doing this, I've changed the functional testing code to be in source functional Scala, because I've moved the source directory for functional tests. And that's what this in does. It changes the scope of that setting that I'm applying, and I'm making use of a setting in a different scope. So, yeah.
Sorry, one more. So the one thing, because you're defining a new fun test that extends from test, then automatically shouldn't fun test have all of the test settings? So it's a little confusing why they're being re-added.
Well, yeah, so there's a difference. If I extend from test and I try to make use of a setting and I can't find it, it will look in test settings, right? But the setting doesn't exist. So the setting doesn't exist, but if I look for the setting, I will look in its parent if I can't find it. So in the console, if I were to write fun:/test, just from doing this, that setting doesn't exist, right? If I have another setting that depends on fun:/test, it can substitute test:/test, okay? So that's the difference there, is you actually have to, if you want the tasks to be available at runtime, they have to be, you have to move them and copy them, right? They have to exist. But if this default.test settings has dependencies on things that, dependencies on keys, so if it depends, like let's say sources is not part of default.test settings, it's defined in another default. When I go to look up fun:/sources, it will look up the task, it won't find the task, so it'll look up the task in test:/sources, right? And test:/sources happens to depend on foo, bar, that sort of thing. So you have to be careful, but the way that SBT defines these defaults, they're pretty complete. You know, so if you move default.test settings, you will get all of them. Anyway, so I hope I answered that to good. Right. All right, so let's say I want to generate some code, and I want it to be included in compilation, right? So code generation is fun. There's always times where you have to generate a little bit of code, and it's handy. In this case, I define a template of object properties, def name, and then name. So let's say I want a Scala properties object that I can put values into at build time and then rely on them in my build to make use of them instead of using a properties file. I want it statically enforced. So I create my template. I create a generate properties file method. This is just Scala code, okay? I'm making use of some SBT APIs, but this is just a Scala method. I create a file object that takes the directory, but underneath the directory, we'll create a build properties.scala file, okay? The directory is passed in here. I write the file. To the file, I write the string where I replace all instances of that name with the name that I'm passed in, okay? So if I wanted to have a bunch of other things in the property, I'd have to have a bunch of other methods. Maybe I have a map of things that I write. Anyway, the point is I'm generating a Scala file, and I'm using io.write to write it. And I return a sequence of files here. Generate properties file is going to return that sequence. Okay, so now in my project, in the configuration of compile, right, I add a source generator. A source generator is a key in Scala of something that will, it's a task that generates a sequence of files. Okay, so what I'm doing is I'm calling plus equals and adding a new sequence of files to the existing sequence of files. So source generators by SBT are automatically run before Scala compilation. So if I need to do any sort of code generation, I can attach a new source generator by taking my dependencies here, using my applicative map call, because this is a task, and passing the values of those settings into this method. Okay? So this is all just Scala code. Right, now if I wanted to change the source generators used for testing, let's say I wanted to automatically generate test files, the only thing I would need to change here is do source generators in test plus equals, okay? And that would generate test source files that only are used in test situations. Okay, so that's kind of a advanced hook that's automatically provided for us from SBT. We didn't have to write any of the magic to make sure that the source is generated and added to the sources list. SBT will use the source generators appropriately.
Just a quick question. So
Yeah.
less plus equal, I think we see that.
Oh, right. So that's old school. You actually only need plus equals here. You don't need the less. Sorry. In SBT 010, we had less plus equals, which was the exact same thing as plus equals. Except one worked on settings and one worked on tasks. Now you only need plus equals. So just pretend that that's plus equals. Sorry. Okay. Yeah, and so source generators, I'm adding a task that will generate a properties file, right? This is a function that takes in some inputs and generates a sequence of files. This here is an initialize of a sequence of files, and I'm adding that sequence of files to that task sequence of files to the source generator's tasks. Okay, it's a little. I should have written out more types for you, but you know it's Scala. Anyway, okay, I can define setting chains. So let's say I want to define coverage tests. I want my coverage tests to be different than my tests. I want that entire flow to be separate. I can define a new config for coverage, but I can have it depend on all of the sources that are in my regular old tests. So I automatically make use of all my unit tests and my coverage tests. But if I needed something else, if I needed some more sources or some other different settings, I can append to that setting, right? So the first thing I have to do is make sure that my sources in coverage rely on the sources in tests, and then I can append values to it afterwards. And so this will take the final value of the sources in test and then add stuff. So it's a really handy way to actually, where I make use of this, I have a native packager plugin, right? So I want to define a way to deploy software on Linux. So I define a base set of things like put this shell script in the user bin file, or in user bin directory, put these jar files under user share Java or wherever the heck it is, right? And I define those in mappings in Linux, right? Then I have specific extensions for Ubuntu and for Debian, where I can add like a Debian changelog file, I can add like a RPM file for Red Hat, that sort of thing. And it makes use of the defaults for Linux, and then I have extensions for the specific configs that I'm using later, right? It's a very, very slick trick to have some sort of base config that people can extend and add to. All right, now let's say I need to define a new task in SBT. This is, a lot of people want to make use of this. One thing I will say, I'm covering this late in the talk because normally you don't need to generate new tasks. If you need to generate new tasks, you might be doing something brand new in SBT and it might be plugin worthy. Okay, so first thing I have to do is define a key. To define a key, there's this task key object with an apply method, and I give it a return type. The return type for this task is going to be unit, and I give it the key a name, and I give it a description. If I were to actually use name, I'm going to get an exception at runtime. SBT is going to tell me I already know of something called name, and it doesn't return unit. So You can't construct this because we're going to end up with type issues at runtime, right? But I can call it something like perhaps foo. Convention is if I define a new key, the name here, which is the one used in the console, should be the same, okay? So when I look at the console and I type compile, which just compiled everything, that is the name of a task key. And if I go into sbt.keys file, I will find a configuration that looks like this and is called compile, right? So I can reference these directly. All right, so after I define my key, I define a method that will execute my task and has my dependencies. Now, someone asked about streams. Most tasks should take in this value task streams that has a set of logs you're going to make use of, okay? SBT defines a setting that just gives you access to stuff. There's a bunch of them in SBT. If I want to know what SBT version I'm using, I can depend on the SBT version key. If I want the log files, I depend on what's called streams, and then I can write to any log file I want. Yeah, so if I'm defining a task where I want to log, I depend on this task streams. So that's what do-foo here is. And I'm also taking in a name. Then I wire my dependencies with my function to create an initialize, and I put the whole thing into a setting, okay? So here, I'm taking name and streams, the keys. I'm using that applicative syntax to then push them into the method, and this will generate a unit, an initialize of unit, initialize of task of unit, which I then apply to the foo key, okay? So this is how I'm defining tasks. This right here is how everything in SBT is wired. If you're going to look at SBT defaults, that's how it all works. All right, so let's say I want to create a zip distribution. So I have a project and I want to zip up a whole bunch of stuff to send to people, and they can just open it up and run something. I'm going to make use of my mappings key. First thing I'm going to do is create a config for it so that I have a new namespace. The next thing I'm going to do is create a method called makeZipDist. This zipdist takes a mappings, which is a sequence of file to string pairs, right? This is that whole mappings concept. I have a file and I have a location in the zip that file should reside. And then I take a directory where the zip should be generated. So first thing I do, if the directory doesn't exist, I make it, right? Next thing, I create a new file object for the location. So this is going to be called myProjectReleaseLatest. And then I use SBT's IO class and call zip, and I pass in mappings and the resulting zip file, and it will zip everything up for me. And then I return the zip file. So now, in the dist configuration, I define a set of settings. I set my mappings to sequence empty first. So I have an empty set of mappings. I set my mappings in package bin compile. I take the package bin compile result. So package bin is a task that packages up my jar. And the result of that task is a file, which I then map to the main jar file, right? So I'm taking the task that generates the file, running the task, getting the resulting file, creating a tuple of that file to the location on disk, right? And then I'm appending that to my mappings. So it's a little bit complicated, but that's essentially what this line is doing, is I'm appending one mapping. I'm appending this jar should be called main.jar. I do the same thing with my docs, right? And I call them docs.jar. And then finally, I define my package bin in the dist configuration to take those mappings, to take the base directory. The base directory is the directory of your project. And then I call makeZipDist, the function. So it's going to get those mappings of sequence of files from this setting and apply it there. Okay, so in SBT, the confusing parts right, are the fact that you're dealing inside of these initialized tasks, the fact that when I write a method, I have to know what all these existing keys are and their types. So when you use SBT, I recommend writing helper methods for everything you want to do. So I know that I want to do foo. I'm going to write a method that takes in some inputs and does foo. Then I have to look through, I have to look through keys.scala and look for the appropriate keys and figure out how to map the settings in the build into my method to make the thing run, right? Then I can inspect those settings and figure out who has configured them, whether or not they're there, and set them if they're not set. And finally, there's a thing called console project. Console project will dump you into a Scala REPL that is live against your build file so that you can run all the methods you've defined in your build file. You can call all your keys and interact with SBT, calling methods directly against the core of it. And the most important thing is if you need help with SBT, you should ask. It takes a while to get into it because there are a lot of default keys, a lot of default flows happening in SBT. And if you want to do something, odds are that flow that you need to accomplish already has a hook. And you just need to find the right place to put something. So the simple build tool at googlegroups.com has a lot of people who are really into this build tool and can help you find the right location. I may not be one of them. I'm usually one of the ones asking. But after a while, you learn where things are. And to be honest, once you learn this build tool, you can take your build and turn it into a plugin that others can use in almost 0 time. So it's amazing how flexible it is and how efficient your code becomes for your build. It does take a little while to get into figuring out what all this means, how to use it, that sort of thing. So I will, I mean, obviously from this talk you can see that it's the code is somewhat terse and there's a lot of meat behind it. There's not a lot of code behind it. It's a very, very simple system once you understand the fundamental concepts. But those concepts are not the easiest to grasp initially. So if you're interested in SBT, feel free to go to the website. Email me, ask. We'll help you out with whatever questions you have. It's a really great build tool once you get into it. So I encourage you to try it out.